So my name is John Walicki, and I am an IBM developer advocate. I speak at conferences, I design and teach workshops, I write tutorials, I do webinars, I mentor at hackathons. I happen to be an expert with IoT devices. I'm here today to talk to you about some of my IoT projects, what I found in my journey to teach about what developers need to know about IoT devices and finding insights from those edge sensors. So edge is a really important topic, and we'll talk about that today. So hopefully you're seeing my screen. What we'll do, I've got a presentation prepared, but I very quickly will go off the rails, and we will do a live demo. Now, I've lit some candles to the demo gods, and if we have to come back to the presentation, we will. But for the next 40 minutes or so, you'll get a chance to join me in my home office, and we'll start from the sensor, and we will find some insights. You ready to get going? Here it is. All right, so what we will do in the next couple of minutes is we'll start with a sensor. We'll talk about some edge gateways and why edge is really important, especially around edge prediction. That's where we're headed. We will send some data over MQTT to the cloud, in my case, the IBM Cloud, where I will receive that data in the IoT, Watson IoT platform. We'll do some real-time analytics as the data is arriving. I'll show you how to do that. We'll bring the data into Node-RED, an open source visual programming technique, allows us to build dashboards and charts, and then we'll store that data in a time series Cloud and CouchDB database in the cloud, because anyone who wants to do analytics wants a data set. So we'll store some data in our cloud, and then we'll start to do some analytics. We'll jump over to IBM's data science portal. It's called Watson Studio, where we'll set up a Jupyter notebook, and then we'll bring our data in. We'll train a model using a logistic regression, which is basically a binary on-off, hot-cold, sensor overheating type of situation. And then we want to deploy that model back down to the edge to do edge prediction, because instead of sending the full round trip to the cloud and back, which we'll do for our training set, what we really want to do is run the prediction local here on my device. And so I'll introduce you to this in a moment. Okay, are you ready? So I typically do this demo with no slides, although I will probably come back to the slides just to anchor us as we move through this presentation and demo. I'll keep coming back to the chart here so that you know where we are in our journey. All right, so my code is available in GitHub. I wrote it as a workshop, and you can implement this entire workshop using the instructions here in this Git repository. Hopefully behind me, you see my Git repo, but you certainly can ping me later or find me on Twitter and locate my directions. So what we're going to do is, so here I'm going to just get rid of the slides because I don't want to do slides. No one here likes slides, right? So there's my Git repository, and you can go and jump down and grab it. It's the STM32MP1 Edge IoT workshop, and I take you through all of the steps. It's a rather substantial journey, and if you can read, you can do exactly what I'm going to teach you today. So I started with a board. I happen to have some great partners in the industry, and we've got a great partnership with ST Microelectronics, and they share with me one of their starter kits. It's called the STM32MP1. It's got, similar to a Raspberry Pi or a Jetson Nano, it's an ARM processor. It, in my case, has a little display on it, which is helpful. It's got 4 USB ports, HDMI, couple of power, Ethernet, and most importantly is in the back, you can connect a Nucleo board, a set of Arduino compatible Nucleo boards. Those of you that are not familiar with the ST platform, it's rather substantial set of sensors that they make. They're a sensor maker, and IBM's not a sensor maker. We are a cloud provider, so it's great partnership. So I took their particular sensor board and I attached it to the bottom of my STM32MP1, and I wrote a little Linux driver. What's cool about the STM32MP1 is that it has a couple of things that's really important. One, it's a microprocessor, so it runs Linux, ARM, A7. It also has an MP4. So if I wanted to do a microcontroller, I can, and a microcontroller is reading the sensor data from my daughter card here, and I'm passing that data to Linux. And now when I'm running Linux, I can actually, let me bring my, so show you that it's running. If I wave it around too much, I will unplug it, I'm positive. But so here it is running Linux, just so that you know. I can do a uname-a, and I've installed Node because I'm going to write some programs with Node today. I will show you that I've got a little Python program that can go query the sensors, and we get from the daughter card temperature, humidity, accelerometer data, gyroscope. We're going to send that data over MQTT to the cloud, just to anchor ourselves. We've already talked about the STM32. We've talked about our expansion board. We're now, so why is Edge important, and why is this particular device, I think, relevant today? Because especially as we hear about Edge and the combination of Edge plus AI becomes really powerful. We can, and we've done for the last several years, connected our IoT sensors to the cloud. We send every bleep of temperature up to the platform, and it's probably not really necessary. There's really no point in knowing, 25 degrees, 25, 25, 25 Celsius over and over again. What you really care about is, normal, normal, normal. Oh, really big variation. I care about the variations. I care about the second order shift, because in any dynamic system, you're going to get a little bit of jitter. I don't care. What I really care about is when the machine overheats, when there's vibration, when there's motion, and that's when I might want to wake up and start to send data to the cloud. So it's the combination of Edge as a model that we can do a little model prediction on. What is normal for this device in my office today in New Jersey versus what would be normal on a production floor in your factory. And so this combination of train a model, deploy a model becomes really important. And Linux gives me that flexibility to, one, manage the endpoint, manage that edge device, push models to it, because it's a dynamic environment. Models are going to change. What works for you is going to be very different than what works for me. I might want to update my model based on additional learning, based on additional data. And so this loop, even though I show it as an arrow here, really becomes a virtuous circle where you can train a model and then deploy the model, train the model, deploy the model based on new conditions. Important to go through the journey though. So let's talk about MQTT next, because MQTT, oh, that got really small on me. Apologize for that. Control plus. So MQTT is a protocol. It was designed, 20 years ago to send data from oil platforms to satellite links. And so packet size was really important. Now it runs over TCP. It's a very lightweight protocol, and it's only got nine bits of header, 9 bytes of header, sorry, and the rest is payload that you can manage yourself. And so it's become the de facto standard. Now there are others, but in many cases, devices are talking to the cloud or to each other through an MQTT protocol. All right. And so it was actually, the standard was created by 2 colleagues. Andy Stanford Clark happens to still be an IBM Distinguished Engineer. And the protocol itself was donated to Oasis, and it became an ISO standard 10 years ago. And there's many implementations in open source, so we'll take advantage of MQTT. Most of the cloud providers today, AWS, Google, and Amazon, and Azure, IBM, of course, are using MQTT as their transport for IoT data. So what I've done is I've wired it to talk to IBM Cloud. But before I take you there, I wanted to spend one more minute talking about the device itself, because the device runs Linux, and I showed you that I had installed Node on it, and that allows me to install Node-RED. And so I've actually have Node-RED. So this is Node-RED running. You'll notice it's 192.168.1.240 on my home network today. So the board itself's got Wi-Fi, as you would expect a small board computer to have. So it's not Ethernet connected, although I am powering it through the white cable, and black cable is just a serial monitor. I can SSH to it, which is what I showed you in my terminal, but I also can open up a remote terminal and write a program in Node-RED, visual programming. If you're not familiar with Node-RED before, you've got a palette of nodes that you can go grab and drag out to, and you can wire them together, and you can, instead of a timestamp, we can inject a string, and maybe that string says hello world, and then you can say done and deploy, and we've got ourselves hello world in 5 seconds or so. Okay, hopefully you saw hello world over in the debug on the right panel. So I wrote a program that goes and queries our sensors. So I read out a proc, all of the sensor readings. I format that into a JSON object, and I'm going to transmit that up to the IBM Cloud with a device type and a device ID and a secret token. All right. So let's go take a look at that, because now you see that I'm sending data to the cloud, and you can kind of see as I shake the thing, I'm sending some temperature, humidity, accelerometer, gyroscope data up to the cloud. Let's put that down for a moment, and we will talk about the cloud offerings, because to do that, we want to jump up to the IBM Cloud. Now I've already logged in, and I went to the catalog, and I went down to the, so we've got hundreds of services in the IBM Cloud catalog, AI, analytics, databases, bare metal, cube clusters, VPNs, anything you would expect a cloud provider to have, we've got offerings for. But I'm interested today in the Internet of Things catalog, and here you see we've got the Internet of Things platform. And so I've created an instance of this, and I started it up, and let me just jump over to it. So here they are. One is called, well, it's a Cloud Foundry app. I'll show you that in a moment. It's an IoT platform instance. I'm going to show you that now. And I also have a cloud database, because I promised that I was going to store this data that I'm sending in a time series database. So I've got three things sort of together as an app. We made that simple as a deployment model because in the cloud catalog, in addition to IoT platform, we've got, we can jump over to the software tab and we can jump down to our starter kits. And in our starter kits, we have a Node-RED. Here it is. So we've got a Node-RED app. So I've taken the Node-RED app, which will run in IBM Cloud. Remember, I'm running Node-RED on both the endpoint and in the cloud. And so it'll be just Node.js running in the cloud, a Node-RED instance, also all running on OpenST Linux, which is a variant. Oh, I didn't talk about that. Let me go back. The board, I said running Linux, so it doesn't run Raspbian. It runs an open embedded Linux derivative, all totally open source, called OpenST Linux. And so I compiled it and I installed open embedded here, Octo-based distro. So those of you familiar with Advantage distributions, I'm a Linux expert, so that was relatively straightforward. I've been compiling kernels for 21 years or something silly. So I'm going to run Node-RED in the cloud. And so I created an instance of that. I showed you here. There it is. It's active. Let's jump into it. And it includes, so I'm running one instance. It doesn't have to be an internet scale app. I could have deployed it to, in addition to Dallas, here it's running in a data center in Dallas. I could spin up instances of it running in DC or Europe or AP or Australia and spread my load. In my case, my sensor is just one of them. I don't really need internet scale connectivity, but I do need a database, I'm sorry, a cloud database and an IoT instance. They're connected. It's a Cloud Foundry app, runs in a container. Okay, so we have it running. I'll show you it running in a moment. But right now, I wanted to drill down inside of the IoT service. So I'm going to hit the launch button. And that will take me over to IoT platform, where I went and I created myself a device. And let me just back up here. So I've created a number of devices, some of them discovery kits, some of them STM32MP1s. And you can see one of them is now connected and active. So there it is, active. What's interesting about IoT platform, IBM's implementation, is we can you set up a certificate. So you have trusted devices. So I trust this device to send data to the cloud, and this device trusts the cloud that it's talking to. So I can do digital certificates. I've already set that up. Takes some time to do all of that. But let's open up my particular device here. We see it's connected. I've got some recent events. Hopefully, every 3 seconds, I'm sending an event. And here we see the last one at 4:06 Eastern time. I've got temperature, humidity, accelerometer, gyroscope coming from my board. If I shake it again, I'll get some different settings. So let's go. So now we know it's connected and everything's good. A few seconds ago. Cool. We are sending our data in a little format called d.temp. So it's JSON. Remember, it's an MQTT packet. I can do anything I want with it. So I'm going to stringify a JSON object, and I'm going to send a d.temp and d.humidity and accelerometer and gyroscope. And if you watch long enough, it will jump around and move. Okay. Fun. Now we've got data coming into IoT platform. What are you going to do with it, John? Well, we're going to write a little program. Wow. And so here it is, Node-RED running in the cloud. And so I went to my palette and I went down to IoT and I grabbed an instance of this. And instead of quick start, I want to connect it. Well, let's do the one that I actually set up already. You see it's connected. It's bound as an app. I'm getting data. Actually, I'm going to get all of the data. And in it comes, here we see it arriving from my board. And there's some interesting data. I'm just going to grab one value out of that. So I grab a switch node and a template node, and I really only care about, it's a change node, sorry. And I only care about the payload.d.temp. Sure, and here it is. It should be over on the right side every couple of minutes. Okay. But that's still boring. I want a chart. John, show me a chart. So I got charts. Node-RED's got a dashboard. And so let's jump over. So I've built some dashboards, which I will show you now. And I'm going to jump over to my dashboard. And so wait, I just told the story already. Quick, look away. So we've got a bunch of charts with Node-RED. Node-RED's got you can extend Node-RED with about 2,000 additional nodes in our palette. Here in my case, I added a Node-RED dashboard nodes, and I can do line charts and pie charts and bar charts, and I got polar radar charts. I don't know what to do with a radar chart. If you can spin up some data science project that knows what to do with radar charts, go for it. But I really just care about line charts, and I've got one here. So Node-RED, you can build a whole dashboard. So in my case, you know, this one just generates some random numbers with a slider and a gauge and a text and a little chart of that random number. So I could build fun charts. And so I showed you there. Now I could build lots of really fancy charts. I showed you already. Let's go take a look at the data as it's arriving. So here's a couple of charts of the data. Remember, let me show you that live too, so you can see the data behind this. So I'm going to plot temperature, humidity, accelerometer, and gyroscope. And so as I shake it and hopefully not unplug it, I am showing you pretty real-time data. I think I set it up 3 seconds. That seemed sufficient for my demo. So let's go take a look at that. So here on another tab, I've got my IoT data. It's arriving, and I'm going to grab temperature and send it to the temperature chart. I'm going to grab humidity and send it to the humidity chart. I'm going to warn on values so I can do real-time alerts here. I promise I would show you that. And I'm going to take 3 values, XYZ accelerometer, XYZ gyroscope, and I want to drop them on a single chart with different topics because we want to show XYZ in multiple dimensions. Okay, so all fun. I'm going to stop doing this. What I'm going to do though is eventually we're going to build a model here on temperature. So I'm going to put my finger on the board for a bit, and we should see the humidity go up or down. What is it doing here? If I can find the sensor there, it should start to go up. Actually, what I'm going to do is I got a space heater next to me. I'm going to put the space heater on just for jokes because I do want to heat it up. And so we're going to set it down for a second and let that get hot because I want to go tell some more stories. And the next, so let's go anchor ourselves. Where the hell are we in our little journey? We have talked about the Node-RED dashboard. You just saw the dashboard. And I'm going fast here because I think I've only got 15 more minutes. Our next little step is to write the data to a time series database. And we're going to spend some time showing you how to do that. And then let's jump over to Watson Studio, where the magic happens. Now I have a tab for this. Okay, so remember that my Cloud Foundry app, remember my Cloud Foundry app? Well, it has a Cloud database attached to it. And I've actually opened that up and I hit the, I hit the launch button, and the launch button is going to take me over here. And now I've got a bunch of databases. I've got, a couple of hundreds of records in them, but I have a database which I just created. It's got 0 records in it. And we're going to go fill in. Let's go turn that on because I don't really want to do data analytics on 0 data set. Let's go turn that on. So I've got a Node-RED flow here, store some data, and we're going to go grab this wire and connect it to our Indy Cloud conference, and we'll say deploy, and we're going to confirm. So what am I doing? Well, I am going to take the data that's arriving from the board. And in my case, I don't care about accelerometer or gyroscope. What I really care about, my model will be built with temperature and humidity. So I create a little bit of JavaScript here. I'm going to grab humidity and temperature. I want times because a time series database needs time. And I'm going to create a payload, which I pass to our Cloudant database. And I just want to store the Cloudant rec that passed that payload in my database. All right, let's go check it out because I've got some records now. And I'll hit refresh on my screen here. See, I did it too long ago. Let's go timed out because I think it's got like a 30-minute timeout. Here we go, 19 records, cool. All right, so here if I go look at our table, we see humidity, temperature, and time, Unix epoch since 1970. All right, so now we got data. Data's arriving, that's super fun. What are you gonna do next, John? Well, we're going to jump over to Watson Studio, which is IBM's data science portal. And you can do this on your laptop, Jupyter notebooks, Spark, Python, R, Java. You can install all of the tool chains on your laptop and do great data science. Go for it. We actually put this all together for you in a portal. You can manage projects, and you can go create a project and create a machine learning. So we've got PyTorch and ML and TensorFlow. A bunch of libraries are all in our, so you would click in and give it a name and connect your data to cloud object storage. We would do all these things. I've already done it. Let's go back. So I created one. It's called IoT Sensor Analytics at the Edge. And I opened it up and it looks like this. So I opened my notebook. So those of you that don't know what a notebook is, it's for data scientists who are lazy and are particularly good programmers. They just want to do cell by cell, and it's sort of like a debugger. You can step cell by cell through your records, and you can watch the results. So in my case, I'm going to spin up a Spark session, and let's go through this here. And I'm going to use, so I'm writing my little notebook here in Python. So I want to do a Apache Spark, and I create a session. Now I told you I had a database. So I'm going to go and read the data records out of the database. And look away because those are my credentials. Don't take a screenshot. And now I've got a training set. I'm going to train on the ones I've already connected. It's getting hot over here. All right, so what do I want to do? Because I want to do analytics on, now I've got a data set. I've got a couple hundred records in my data set. And what I trained it with, so my training set was normal temperature, room temperature, and then hot. So I have both hot data and cold, normal data. And you see here a mix of that. I've got a couple hundred records of each. And so there they are. And so I classify the two into a class 0, which is normal, class 1, which is hot. And we want to take a look at class 1, which is all the hot temperatures. So this is, I don't remember, maybe, humidity 30 degrees. is hot. Let's go take a look at our chart here because I'm curious if it's getting hotter or not. And yeah, it's starting to get hotter, right? 30 something degrees. What's our temperature now? 30.7. Getting there. Because I wanted to start throwing alerts at me. Let's go over here. So where are we? Got 10 minutes left. We are going to make it. All right, so I've got a bunch of data. So I've got 50 records of normal, 50 records of hot, and it's got a bunch of temperature readings. Now I want to go, and there they are, blah, 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 put it in a nice table in my Jupyter notebook. Now the magic comes here. Now, I'm not a data scientist. I am an IoT guy, but I've got some really bright data scientists on the IBM team that are similar dev advocates. And so they helped me write a little logistic regression here. And I'm going to pass my data to a logistic regression algorithm. Those of you that do not know what a logistic algorithm is, sorry, there's math involved. It is essentially this. So the first sentence, so you want to know pass, fail, win, lose, hot, cold, dead or alive. And we're going to do a fit on that data. And so that's what this logistic regression is going to do in our Spark pipeline. Okay, so I pass the data to that, and I get myself out of that system two things. I get the coefficients of where the x, y, it crosses the axis, and the coefficient slope of the line. And I can now, these three things are my model. And I want to send them, now I've got a model that says this is hot, this is normal. I want to send that back down to the edge. So I'm going to take these numbers and I'm going to drop it into, see, I'm throwing alerts now. Yeah, throwing alerts. Cool. 33 degrees. All right. But what I want to do is send, so actually the board's sending it. Let's go. I want to send the data back down to the edge. So I can type in my numbers here, which I've forgotten, and I can press the submit button. Now, remember I was sending data from the board to the cloud. I want to do the opposite. I want to send a package, the model, and I want to send the data down to the board. So I did that here. I fill it in. Let me go show you that code over here. Send edge model. So here's my dashboard. I'm going to take the intercepts and coefficients, and I build a payload, and I send it down to my edge device. Now, Node-RED on the edge is going to catch it. So here I am. I'm going to catch my edge model and from Watson Studio. And so I've got myself now, this is running local. You'll notice now I'm running local on my board, and I can, hopefully it arrived. And so now I've got coefficients on my edge device, and I want to, so now as the data is, yes, I'm querying it as it's local, but I want to be able to do a prediction of it. And hopefully, and it should look like this. All right, so there I'm doing alerts, and so there was an alert on the edge. So I can start to do alerts on the screen here based on the data as it's sending up to the cloud. So that was kind of cool. That was a pretty fast journey. Let me go anchor ourselves again, because I trained a model, and then I deployed the model, and now I'm going to do edge prediction. So I now have a model on the edge device that I can disconnect from the cloud. I don't need to send the data to the cloud anymore. I can disconnect the Wi-Fi and run the model, the edge model, here on the STM32MP1. You can run it on a Raspberry Pi or a Jetson Nano, which I've knocked them off my board here. Here's my cluster of Raspberry Pis. Here's my Jetson Nano. It's connected to, it's connected to video. I'm doing some video object detection with my Jetson Nano. So STM32MP1, I show you here in my little journey, but you can imagine I can do it on other types of Linux Edge devices. That's going to complete my demo, and just encourage you to follow me on Twitter, catch up with me and my projects in GitHub. You can find me on developer.ibm.com. I write tutorials about IoT and Node-RED and AI and Edge Analytics. Connect with me on LinkedIn, and I would love to help you build your projects, especially as Edge becomes more important. I think we're going to be in for a fun year after this coronavirus comes to conclusion. I will take some questions. Actually, I think we're going to go, and Calvin will do some closing remarks. So I don't know if I'm going to have a chance to jump into the breakout room, but certainly we can continue to have a conversation in the hardware IoT channel.